Question 10, we're given the product rule from the formula booklet. We're asked to turn it into integration by parts. So we want u dv, so let's leave this guy there and bring this guy across and rewrite it as u dv dx is equal to the differentiated product rule u of v with respect to x, and that's going to be minus v du dx. You can see your own here, you just need to get rid of the du's. If we integrate this guy, we're going to get uv. So we integrate both sides with respect to x to keep everything the same. We'll have our dx's in, and we'll end up with the integral of u dv is equal to uv minus v du. A bit untidy, but straightforward enough. We're asked to then hence evaluate this guy here. So we're going to let u, using the LATE, we're going to get u equal cos x, and we're going to let v du, dv equal e to the power of x. So du dx is going to be equal to cos, when we integrate it, goes to minus sine x. So du is equal to minus sine x dx. And if dv is equal to e to the power of x, if we integrate dv, we get v is going to be equal to the integral of e to the power of x, which is e to the power of x. So we rewrite our expression as we've separated into u dv. So u times v, u is cos x, v is now e to the power of x, and then we have minus v du. So that's going to be, the integral symbol, the integral of v, which is e to the power of x, du, which is minus sine x dx. So you can see again we have another product rule. So I'm just going to tidy this up. It's going to be cos x e to the power of x, and then it's going to be plus the integral of e to the power of x sine x with respect to x. So now we have to let u equal sine x. So du dx, as the dog has a bad dream, is equal to sine goes to cos, so cos x. So du is equal to cos x dx. Then dv will be equal to e to the power of x. So we integrate these guys, both sides with respect to x, we get v is equal to e to the power of x. And then subbing in again, we're going to get, so we already have cos x e to the power of x. Then it's going to be plus the integrated by parts part, so it's plus uv again, doing it again. So sine x is u, second part, sine x by v e to the power of x minus the integral of v du, and v is e to the power of x, and the u is cos x dx. So we started off with this guy here, so I'm just going to write him again. The integral of e to the power of x cos x is now equal to this whole expression here. So this is where we need to recognize that this guy here is the same as this guy here. I just left out the dx. So if I bring this one to the left, I'm going to get two of them. So I have twice the integral of e to the power of x cos x dx will be equal to, and I can factor out e to the power of x here, e to the power of x by cos x plus sine x. And if I divide by 2, I'll get the integral of e to the power of x cos x with respect to x is equal to e to the power of x over 2 by cos x plus sin x. End of question 10.